Maybe it's good to start recording now, Jeanette?
Yes, I just did.
Okay, everyone, welcome in this call. I will mute all of you except myself, that is to suppress any background noise. Welcome this morning, this afternoon, in this Tech Talk, which is organized by the Dutch Embassy and the Dutch Consulate in Canberra and in Sydney, on the one hand, and ENVAQUA on the other hand. ENVAQUA is the Association of Dutch Water and Environmental Technology Companies. We have been in touch with Dai Forterre and Alida Ritsema for, I don't know, more than a year, and we organized a Tech Talk last summer on the reuse of organic waste, processing of organic waste. And while we were having this Tech Talk, the idea came up to have another one focusing on water reuse, and that's where we're here today. What a Tech Talk intends to do is addressing a societal challenge that we can help, that we can bring further by applying water and environmental technology. We are all engineers, in fact. That's what we saw. In our hearts, we're often more, let's say, more technical experts than commercial cracks. And we simply love to do good and love to leave the world a little bit better than we have found it when we came here. Today we are trying to. We were briefed in different sessions that were prior to this Tech Talk about the challenges in Victoria and in Latrobe Valley in specific, the intention to move away from this fossil fuel-based economy to other ways of working, ways of adding value. And in many of these cases, whether it's in agriculture, whether it's in horticulture, whether it's in dairy, whether it's in brewery, whether it's in industrial processes, water plays an enabling role or a limiting role. And that is, well, Australia has a lot of rain and flooding sometimes, and droughts on the other hand. And what we see and what we like to address today is to see how we can reuse water in industrial applications, in agriculture, in horticulture, in other applications, reuse water to enable this economic, well, growth or new economic initiatives. That's the bigger picture of today. We have invited several, I should say, Nicola, you played an important role there together with Diana and Lida. We invited guests from all kinds of organizations in Australia that are in a way are facing water shortage in their operations. As you can see here, so Frederick, Chris, Greg, Simon. Simon, we was one of the presenters in the previous Tech Talk that we had last summer, or last winter, just how you name it, of course. Andrew, David, and Stuart. So what I am aware and what I should share with you is that we had some, for good reasons, we had some issues in bringing in all the presentations from Australia, which is not a problem. So what I like to do is, after my introduction, give Frederick, Frederick is not here, he's in the plane, but then let's start with Chris. Chris, Greg, Simon, Andrew, David, and Stuart. Let's give you the floor and introduce your situation. In what way are you feeling water shortage, or in what way do you need water shortage? Do you need water in your processes? Tell us a bit about your cases. This can be rather informal, take 5 minutes or so. If you want to share your screen, please tell me, then you can share your screen and we'll have a look at your slides. If you are using slides, then I ask you not to take more than 8 minutes in your presentation. Then we have a very short break. It will be 2 or 3 minutes just to grab a coffee and have a short, otherwise 1.5 hours is a bit long in an online call. And then maybe, Annette, you can show the program sheet again. Then we'll move to the Dutch presenters. So Michel on behalf of VDH Water Technology, Willem Baak of Water Future, and Thijs Wolbrink of Nijhuis. So all these three Dutch companies are working in this field in different roles, different ways, different projects, different approaches. but I think and hope that their presentations will inspire you in how we can take this topic further. So there is this chat function, obviously, as you all know, after 1.5 years of Corona. Please use the chat. You can leave there your comments, your suggestions, your sales pitches, your all kinds of thoughts that you want to leave there, or questions, put them there. I will ask the presenters after their presentations also to keep an eye on the chat and start answering eventual questions right away. And I will also keep an eye on the chat and bring some of the questions back into this call. Nicola?
Ignace, I'm not sure if I'm missing him or not. I don't see Chris from Flavorite online just yet. Andrew Bulmer is here from Bulmer Farms. Would you be happy to start there?
Sure. Yeah. No, let's do so. Yeah, that's cool. So please take the floor then.
Sure. Hi, everyone. Thanks for putting this on today. Bulmer Farms is a salad production business located in the eastern part of Victoria, one of Australia's largest producers of fresh salads in the country. We have our own wash line facility based in our pack house with some Dutch technology from a company called Saur that we implemented. First ones in Australia to implement that technology in Australia. When we are busy through our pack house facility, we can use up to 1 megalitre of water a week. And at the moment, that water is not reprocessed or treated any other way. It's just returned to the environment once we're finished with it. So we definitely see a huge opportunity to recapture that water through our pack house production facility, either treat it back to a potable state to then reuse for the facility, or at the very least return it back to irrigation water, because when we face drought conditions over here in Australia, they can be quite severe when we're in the midst of a drought. So that's a really quick pitch from our end. I'm happy to answer more questions from other people. I didn't have a presentation, I'm sorry about that, but basically in a nutshell, that's our issue that we face at the moment that we want to do something about moving forward.
That's excellent, Andrew. And I have two questions, in fact. The one is, how is Australian legislation when it comes to refeeding treated water back into a food processing industry? In the Netherlands, we have quite severe laws, which is really, we have trucks that transport livestock. They need to be flushed with drinking water because it's part of the food chain. It's ridiculous, but that's how this works. Is it the same in Australia, or how do you see this?
There's another growing region in Australia called Werribee, located in Victoria, that in the drought really struggled to get access to water. They ended up getting access to wastewater that was treated back to a standard that the microbes obviously weren't that harmful for vegetables. The biggest problem that they faced was salt. They already had high salinity in what they had, but the salinity levels of the water that they were accessing at the time was quite difficult for them and their crops. So they had other issues with that. I suppose there's, depending on where you are or what water you've got access to, there's different parameters that you're going to have to consider before you can then treat it and reuse it.
Okay, well, that regarding the salt, I know that Willem Baak, one of the Dutch presenters, will address this specifically. So I think you should take good care when he's, or listen well when he's presenting. What about how many megalitres a week did you mention?
Probably a megalitre a week, so roughly around 50 megalitres a year, which is, you know, a significant volume that you could irrigate. You know, for vegetables at least anyway, probably 30 to 40 acres, I suppose, off that water if you had it available for irrigation, you know, cumulative at that point in time. Okay.
Thanks, Andrew, for this introduction. Yeah, Nick, I'm slightly losing the overview of the presenters. I know that's who's next. Shall I ask Simon to be the next in line?
Simon's online. I'm just having a quick Craig Bosch. So Opal is online, and Gippsland Water is online, and Agriculture Victoria are online.
Okay. Well, let's start with Opal then. Presenter of Opal, can you share your situation?
Yes, I've got a short presentation, so if you allow me to share my screen.
Sure.
It's loading.
Yep. There we are.
You see that? Yes.
Sure.
Is it a full size screen where you are, or is it?
Yeah, yeah, more or less, but it's great.
Okay. So yeah, my name's Craig Bosch. I work for Opal. So we're a pulp, paper and packaging company in Australia. We own the Maryvale Pulp and Paper Mill, which you can see in the picture there. It's quite a large operation. It uses or takes in 65 megalitres per day of fresh water into our operations. In 2017, we looked at ways that we could leverage the infrastructure that you're looking at, and also our access to resources such as water in regards to improving the profitability of our business. That led us down the path of recirculating aquaculture, and we approached a joint venture partner called Mainstream Aquaculture to build a recirculating aquaculture facility adjacent to our pulp mill. So you can see our pulp mill in the background there, to produce barramundi. And we decided that it would be a staged approach, with our staged one producing 3,718 tonnes per year in the full first year of operation of barramundi. There's a lot of synergies with recirculating aquaculture and particularly bleach pulp and paper manufacturing, but I'll just talk about the water. So that stage one facility you're looking at will have a holding capacity of 42 million litres of water in a series of tanks. To keep the fish alive, we have to exchange that with 8% fresh water per day, so roughly 3.5 megalitres per day of fresh water, because the nitrate levels get too high for the fish. So we will take fresh water from our Mundara water line. We will use waste heat from our site, so that will reduce the amount of cooling towers we have to run. We will use our existing carbon dioxide and sodium hydroxide systems to produce sodium bicarbonate to add some alkalinity to that water for the fish. The water will be heated to approximately 30 degrees because barramundi is a warm water species. And that's one of our strategic advantages, is producing a warm water species in close proximity to the major population centres of Australia. If we've got 3.5 megalitres of fresh water coming in per day, we have 3.5 megalitres of effluent leaving. That effluent is full of nitrogen and phosphorus. So if you look, we have our own effluent treatment facilities on site, and the area where you can see the bubbles there in the centre, we have microorganisms that live there, and we actually have to buy in phosphoric acid and urea to supply the nitrogen to keep those alive. So this stage one is roughly sized so that we can largely replace a lot of those chemicals with the fish effluent to keep our microorganisms alive. Our plan in the future is to grow much bigger. So this is with stage two. So our production goes up to 11,000 tonne a year. And the plan behind that was so that we had the economies of scale to produce our own fish feed. And there's a whole lot of stuff going on, I know, in the Netherlands with black soldier flies, and in Europe with wood waste to use to produce a single cell protein in salmon food and tilapia food. So there's all these opportunities for us locally to start producing our own fish food once we get the economies of scale. However, as we grow bigger, that water requirement becomes a lot bigger. So, and the nutrient load for our effluent treatment facility becomes too much. So we would have to change our current processes. But the best way to remove those nutrients so that we can then use it to produce pulp and paper. So the concept is we use the water to grow the fish first, and then we remove the nutrients so that we can then produce our pulp and paper. So one of the ways in Australia that's currently being used, I'll just play this for you. It plays. This is not, it doesn't look like it's going to play, but it's a nice video. Yeah. So that facility is in Australia already. This is in Quebec, Canada. So this is a craft pulp mill owned by Resolute Forest Products. They are supplying water and heat to a cucumber greenhouse. They're also capturing 30 tonne a day of carbon dioxide to supply. So with our concept, okay, we grow our fish in the water, the effluent leaving is full of nutrients, then we can go to greenhouses where the vegetables or the berries can remove the nutrients, and we can also use that opportunity to capture carbon dioxide from our site to feed into the greenhouses. However, we would need to follow that with a polishing stage, and we would need to do something like this because the liquid effluent leaving the greenhouses would still be quite high in nutrients. This is also in Australia. This is in Queensland in Australia. This is large-scale industrial algae production aligned with aquaculture effluent. So this there's a huge opportunity in Australia to start producing more algae products. I'm not going to go into that today, but so our whole overall concept is about, you know, we have this large allocation of water at the moment that we just produce pulp and paper with. In the future, we'll have our own manufacturing ecosystem where we grow our fish in the water first, then we produce our vegetables or our berries, then we produce our algae products, and these processes are cleaning up our water, so then we use the water to produce our pulp and paper. So we're essentially producing 4 products as opposed to what we do is currently 1. Thank you. Under 8 minutes, I hope.
Excellent. Now, Greg, it's a really, really inspiring way of thinking and of actually acting. It's brilliant how you combine the problem of the first process is the solution for the second and the other way around. It's really, really clever. And so thanks for this presentation. It's great. I am aware that both Thijs and Nicola, I saw you see your hand. I know that both Thijs and Willem will get back to the nitrate, to the recovery of nutrients, which they have experienced in different other projects. So you will, I'm sure you'll like their presentations. Nicola?
So just a question for Craig. So Craig, is one of your, just so I can crystallize it in my head, is one of your challenges the water that you have to exit, and what to do with that?
Only when we move to stage 2. So stage 1's designed so we don't need the synergistic businesses. It's just aquaculture and our business. But as we expand, we can remove the nutrients using chemical processes, or we can actually try and get benefits out of them with use those nutrients to produce other products. So. And
just for the benefit of our Dutch colleagues, Craig, correct me if I'm wrong, but when this is at full operating level, this will be one of, if not the largest aquaculture facility in the world. And just so you all know, the company they're partnering with, Mainstream Aquaculture, Craig, if I recall correctly, that company currently, for every 5 barramundi eaten in the world, 3 of those come from fingerlings provided by Mainstream around the world. Is that right?
1 in 3. So
1 in 3. There you go.
Consumed anywhere around the world is produced by Mainstream. So barramundi is probably not a popular international fish, maybe not available in Holland, but it's a native Australian fish that will grow just like the salmon industry has grown. There needs to be a white flesh species, the same as salmon, which is pink flesh species, to fill the gap, because there's currently peak wild caught fish globally was in the 1990s. So all future production to meet consumer demand needs to come from aquaculture. And there's a lot of opportunity in the white flesh. So that's the picture you can see there is a white flesh fish.
Nice. Well, this is really inspiring. So thanks, Greg. And I think we should also, the Dutch presenters, I think they will also give their thoughts on possibly how you can reuse the water, not in agriculture purposes, but maybe in the paper mill as well at the same time. But let's see how the others will take this up. Let's go, I suggest, to Gippsland water. And then I saw Stuart has come in, so then we'll give the floor to Stuart after Gippsland.
Thank you, Agnes, and good afternoon, everyone. If you don't mind, I would like to share my screen, if that's okay. Thank you. Please let me know when you can actually see it.
Yeah, all good.
Fantastic, thank you. So I've only got 4 or 5 slides. So just to reintroduce myself, Simon Aquilina from Gippsland Water. I look after commercial business. and in essence, I'm one of the, or my teams are one of the biggest reusers within our own business in regards to reuse of water. Let's see if I can get this to work. Has that changed, Ignis, or not?
No, we're still seeing the opening slide.
You try another screen. Sorry, I'll just unshare that if I can. Is that showing the second slide?
Not yet.
Still showing the first?
Yep.
What I may do, I may just have to talk you through what I've got. I can't seem to get this to work at the moment. So in essence, at Gippsland Water, we treat approximately 25 gigalitres per annum of domestic and industrial wastewater. We reuse around 1.5 gigalitres per annum, and we reuse that predominantly internally for agricultural purposes, but there are also some minor operations and third parties that use it potentially for golf courses, sporting fields, and we've even got a couple of third party dairy farmers that use it, but they're relatively low volumes. Internally, we may use some of the treated or reclaimed water for processing purposes, such as cleaning of screens and the like. The majority of our water either meets Class C or Class B water, but we do have a capacity through our Gippsland Water Factory to produce a Class A water, which we can supply. We have a link that can supply to actually to Opal, who's online with us, for some of their internal paper manufacturing processes. I did have some photos, but unfortunately, like I said, I can't seem to share them at the moment. Some of the challenges we have are quite varied. So regulation's one, and regulation in the sense that it can be a blanket approach, and it can require very high quality standards, which is not always fit for purpose for the end use. So in essence, we can over-treat the water for a end use purpose that might need a lower quality water. And I think the Opal one's a good example of that, where it's a completely closed use system. It's a completely closed system. However, our regulation states that because it is going to be used in an area where I guess humans are around, it has to meet Class A, which actually has even more treatment than our potable or drinking water processes. The other challenge we've got is obviously the location of our water resources. Generally, where we have water, we may not need as much, and unfortunately, in the drier areas of our climate, we won't have that water available. So, actually, getting that water and just getting that water to the areas where we need it can be quite costly, and can be quite cost prohibitive. In addition, is also the quality of the water resources. So, depending on what we need it for, we have a large conduit that runs about 100 kilometres, and down that particular conduit flows around 25 million litres per day. Now, it runs straight past a number of our agricultural enterprises that we have, and quite a lot of regional areas. But the issue is that it's high in salt. It's too high to actually be used directly for irrigation purposes. So it's cost prohibitive, in essence, to reuse that water. Unfortunately, that goes through a set of lagoons at the end of our system and then out to the ocean. And really, in our region, there's probably no great driver, and public perception is also a concern. So public perception of reusing water that comes from domestic effluent. There's still a lot of education to be done around that. There are a number of schemes throughout Victoria, but it's fair to say that the volume going through that is not great. and the perception is still that that the community would prefer to use raw water resources from our catchments as opposed to reuse water. And when I say no great driver, a number of our major customers, and Opal being one in the paper industry, but we also have multiple power stations as well as food manufacturing plants. They already have large allocations generally coming from raw water supplies. And in our current environment, where there's not a great strain on that, and we actually have got quite good climatic conditions, there's no great driver for using of reuse. I think the closest we ever came was probably 2010, when we had one of our severest droughts just before it broke. And Toowoomba in Queensland was probably the nearest it's ever been, or anywhere in Australia has ever been, for reusing domestic effluent as potentially a drinking water supply back into their main catchment dams. But we have opportunities. So as I said, we're in a rural area. We have large agricultural activities throughout the area. We've got large industrial users of water, and we've got continuous streams of wastewater. Unfortunately, it's just not the right quality and in the right place. So there is opportunity. It really becomes a question of the economic viability of actually getting that water to the right end use, to the right customer at the right quality. Ignis, that's about it for me. And apologies for the presentation. I do apologize.
No, no problem. No problem. And maybe you can share your slides later on with Janette or myself, and we will make sure that people can download them online on our website. So we'll make sure that people can have a look at the pictures afterwards anyway.
Yeah, no problem. I'll try and get that through to you.
Just a few comments. I know that Wilfred will address when it comes to this upgrading to this Class A water, disinfection may be an important thing, and that is something that Michel will address later on. Also, interesting what you mentioned about this, the public opinion about water reuse from wastewater treatment plant effluent. In fact, in the Netherlands, we have and I know a case in Australia as well, where the way we do this is we discharge the wastewater treatment plant effluent in a river, and 100 meters further, we extract raw water from the river, which is, in fact, Switzerland and Germany are ahead of us with the River Rhine. So we drink German, well, but
look, in essence, we're in the same situation. In this, indirectly, we actually recover that water further downstream. Unfortunately, it's not seen like that from a public perception perspective. They don't quite see the link. However, if you were to supply them water directly from a treatment facility, that link is a lot more obvious.
Yeah. Now, and also, and we have now in the Netherlands, we have just a post of the CEO of the largest Dutch drinking water utility. He made a post the other day that he is all new households that will request new connections, that he may have problems actually delivering the water to them. So we have, in the wettest country of the world, which I consider the Netherlands to be, we have water scarcity coming up. So I think the public opinion, because there's no alternative, may change anyway. So, but well, let's see how this will work. Thanks, Simon, for being here, and please listen to the other presenters. Well, I'm sure you will.
Indeed, pleasure. Thank you.
Stuart, can I give you the floor? You just joined, Stuart Carson.
I have, Ignis. Thank you very much. Good evening, good morning, good afternoon, everybody. I apologise, I was a bit late joining the call. I also have just a few slides to share. So I shall share my screen, and hopefully the technology works for me. So I am I'm the CEO of Borough Foods. We are a dairy company based in South Gippsland. We process about 350 million litres of milk per year, which we collect from regional dairy farms. There's a photo of our factory I hope you can see on your screen there, with the beautiful rolling green hills of Gippsland. Water has certainly been an issue for us over a number of years. We've been on this site for 30 years, but the site itself has been around for over 100. The water was supplied from a small dam that the local water authority ran. In the last 3 years, that's now been hooked up to a large metropolitan system. So our water security has significantly improved. However, we've invested in some water reuse and recapture technology, which I'll explore a little bit further. I thought I would just share with you sort of two parts to our business. The on-farm side, we don't actually run dairy farms ourselves, but we collect milk from about 200 milk supply partners. Typically, we have about 30% of our supply partners would have some form of decent irrigation on their property. All of our dairy farmers will have washed down water from the dairies or from the yards that the cows are coming up in, or could be feed pads. Very much pasture-based systems down here in Gippsland. So all of that effluent runs into an effluent pond, and that's necessary and a requirement of dairy farms here. And then, as we say, about 30% would irrigate that. Because we have a pretty high rainfall area in Gippsland, it's usually only summer and autumn where that irrigation would occur. Some farmers will have enough dilution to irrigate directly. Some will have to dilute. And particularly with fertilizer prices skyrocketing, I think they've tripled in the last month on the back of some of the Russia-Ukraine crisis. And no doubt the same in Holland and other parts of Europe. It's becoming quite an economical way of getting some nutrients back onto the soil to help with pasture growth. So that's pretty common with most of our dairy farmers. I won't go into too much detail about that. More about us in our factory. A little bit of a complicated slide. I'll try and keep it simplistic. The factory itself, as I said, we process about 350 million litres of milk. We have dry ingredients, we have vegetable oils. We make milk powders, we make infant formula, we do frozen milk concentrates and frozen creams. And then we do bulk products, so liquid milk, liquid creams in various concentrations of fat and protein. So quite a versatile and agile, and as a dairy facility goes, quite a complex little facility. Some of the outputs from all of the processes, largely our milk evaporators and dryer evaporators, and we've got a number of membrane plants across the site. We typically have a milk condensate. We have cooling water from a lot of our pumps and motors and things. We have, when we do our infant formula, we call that nutritionals. We have a very high quality water, so we go through a cleansing system. So we take the bad side of the membranes, if you like, for further treatment. And then we generate liquid waste through our cleaning processes, and we end up with, we have some wastewater, which is usually quite salty because it's been using cleaning chemicals, typically caustic. We do have a recovery system in place. We recover, I think we've reduced our consumption of caustic by somewhere around 70% through our recovery system. But we still end up with quite a large salty waste stream, which goes down to a municipal treatment facility. The rest of the outputs, if I just think about the water process there, ends up as inputs into we have an RO plant where we concentrate the water, and we use this as a reuse facility. So the milk condensate, cooling water, nutritionals treated water in particular, ends up back as clean water. It's potable. We add a chlorine dioxide to that to give it some chlorination, and we'll reuse that through our cleaning processes or for processed water in our factory. And of course, the other side of those membranes ends up as wastewater. We've quite a large and complex wastewater treatment facility. However, by the time we sort of boil it all down, we end up with a liquid stream, what we call a low solid stream, which goes to a municipal trade waste facility. And then we have what we call a high solid stream, which contains some organic matter, a bit of fat and protein that's left over from our processes or our cleaning processes. And then with quite a lot of nutrients as well. We run that through a radial fan press, which is on the right-hand side there of the screen. We add a polymer to that to help with agglomeration and to help bind it. And we end up with about a 19 to 20% solids mix, which we then send to another waste treatment facility for eventual composting. I think it takes about 12 months before it goes through the process of breakdown into composting. That and the outputs of that are liquid effluent, which goes to the municipal plant, and these agglomerated solids. So that sort of gives you an idea of some of the processing and capability that we use, and some of the investments that we've made in water reuse. But just to give you some numbers around that, we process between 700,000 and 1.5 million litres of milk a day, very seasonally dependent, based on the pasture system that we run for our dairying down in Gippsland here. We still purchase around about 1,000 megalitres a day of town water and recover about 800 megalitres. We could invest in further filtration plant to do that. We just haven't found it economically viable to do so just yet. And particularly now that we've got a larger guaranteed supply, because our inbound water, we call it town water, is linked to now a metropolitan system. We produce around 30 tonnes a week of agglomerated solids, which goes off for that eventual composting. And our liquid effluent is somewhere in the order of 1 to 1.2 megalitres a day. So there's quite a lot of volume through that. I guess some of the opportunities that we're continuing to pursue, particularly as fertiliser prices are going up, and I've mentioned that before, removing some of that organic matter and then being able to use the liquid effluent as a supplementary fertiliser. It's pretty high in phosphorus and potassium in particular, not a lot of nitrogen in there, which our dairy farmers would like. But the issue we have at the moment is there's still some organic matter in that liquid effluent. And of course, we can't spread that without some degree of biodegradation. Another option we've looked at is regarding the agglomerated solids is to use a biodynamic polymer or something that will break down on farm and also remove the organic matter. And then we could use that. We could actually spread that on farm as well to provide some further nutrients to aid pasture growth. And our largest challenge, to be honest, is this salty discharge. I think every dairy company in the world has the same issues. I'd love to hear if there's some thoughts of the technology that's being invested in Holland. But largely for us, it ends up going out to the sea. So for us, that's quite a long process to get there. It's quite expensive. So we're trying to find other means or alternates. And Craig, I was really interested in some of the aquaculture things you were talking about earlier as I joined. So look, that's a bit of an overview of Borough and our reuse and where some of the opportunities lie moving forward. Thanks for listening.
Thanks, Stuart. Great presentation. I was preparing the question, what can we do for you? Because you have it so well organized already, but you left a few opportunities there on your last slide, so that's great. And I'm sure that the Dutch presenters will respond to these opportunities. The organic micropollutant removal is a topic in the Netherlands, definitely on wastewater treatment plant effluent, but also in other processes, and also the removal of salt and sodium. That's something that Willem will address. So I hope we can inspire you in the presentations to follow. Nicola, do we have a presenter left from Australia now, or
Agriculture Victoria?
Yeah, I think that's the last presentation from Australia, right?
Yes.
Okie-doke. Well, then let's give the floor to Agriculture Australia.
Greg, how you going? I again have a couple of slides I'd like to talk to, if that's okay.
Sure.
I'll get them.
Yeah, we see the opening screen.
Very good. So my name's Greg Morris. I'm the Senior Technical Officer at our Ag Victoria Research Farm at Allenbank, the Allenbank Smart Farm. So, and again, want to talk to you about water capture and some of our reuse challenges. And it probably goes really well after Stuart's explanation of some of the normal practices that happen on dairy farms, in our pasture-based sort of system. So, trying to make the topic short, this has been a subject that I've probably struggled with and tried to find a resolution to probably over the last couple of years. So I'll just sort of talk to this photo here, if I can get it happening. Next one.
Yep.
So basically, the main issue we have is over the past probably 10 to 12 years, the infrastructure of the dairy farm itself has increased significantly. So including barn type areas, feed pads, we're a commercial dairy farm, so we milk 450 spring calving cows, but then we also support 15 scientists that conduct their research on the farm at Allenbank. So basically, due to these infrastructure increases, our effluent pond system is just not large enough. The main problem we're having with this is not only, I suppose, the increase in production, but the increase in the surface runoff area that's being exposed to these effluent pits. If you on the left of the screen, we've got one of our collection points from the feed pad here. So basically, through the winter or the wetter months of the year, the amount of water that's collected and directed to this effluent pit, which is directly pumped to our digestion ponds, is increased greatly. This is fine. It's a closed system, so you know, in those wetter months, there's an abundance of water for our washdown processes. But the problem we're having is or what I was trying to work out was how I could divert the different qualities of water that were running through to this pond system. So it's fine when the area is clean and say there's no animals on the feed pad in this area here, but in those high rainfall events, and we can feed up to sort of 250 cows on this area here for between 4 and 6 hours a day. Those heavy rainfall events are sending that slightly, I suppose, compromised clean water sources into our effluent system. The main and another problem associated with is that there's the risk of these ponds overflowing, and eventually in those high rainfall periods, it's a possibility that they could re-enter the waterways untreated. We do have an effluent system. It services about 20 hectares of the farm, but again, in those wet periods, like Stuart mentioned, it's just not logical or not possible to be spraying that effluent on the paddocks. I've probably gone through and made as I mentioned, I've been trying to work out how to resolve this issue. So what I was thinking, or what if it was possible, was to basically develop an automated water diversion system based on water quality, whether that was turbidity or nitrogen content. But this way, I'd have the ability to redirect the water before it entered our pond system, based on the quality. So fresh water or surface runoff that was clean enough to, say, fill our washdown tanks, or even our clean water or rainwater reserves, and then overflow then down back to the waterways. The second part would be this slightly contaminated, being water that was, would you say, the first part of the rainfall that was contaminated, whether it was with cow manure and effluent and or other parts, such as silage, stack runoff. And then thirdly would be our standard type high effluent content water that we've built or designed the system to manage. In conjunction with this, I suppose where this has become more of an issue is we are looking at trialling or designing a biodigester for a pasture-based dairy system. And I think the main problem we're having with that design is being able to feed this digester a consistent, regular volume of effluent that would be suitable for processing. So yeah, thank you for that, and I would enjoy any input, and definitely, and going on from what Stuart said, there definitely would be some options for co-digestion, I think, with that your radial press digestate and possibly increasing the benefits of operating a digester at the dairy here. So thank you.
Thanks, Greg. Thanks for your presentation. I think regarding this digestion, it's an we have some companies in our association who are specifically working on digestion of organic stuff and producing biogas, and it's a bit, we have the water companies today in the call, but we can also continue to explore how we can bring digestion technology to Australia as well. I see in the chat it's quite vivid already, which is great. So Simon, thank you for answering. Stuart, thanks for being online and answering some of the questions. I suggest it's 9:20 on my computer. I suggest we take 2 minutes. So 9:22, we're back to grab a cup of coffee, grab a glass of water, and then we'll jump into the presentations from the Netherlands, starting with, I think we have, Willem Baak first, Michel second, and Thijs third. So see you back in 2 minutes.
Thijs, zou jij niet beginnen volgens het schema?
Ja, ik heb mijn agenda iets omgegooid, dus ik heb de tijd. Dus ik houd me aan het huidige programma, is prima.
Oké, want dan weet ik dat ik zo begin met presentatie te delen van Willem, denk ik.
Dat is prima, geen probleem.
Oké. Ignas,
ja.
We beginnen zo eerst met Michel, dus met VDH. Okay. Daarna Willem en Thijs als laatste. En Thijs deelt zijn eigen presentatie.
Prima.
Anders moet hij 48 keer volgende zeggen.
Helemaal goed. Helemaal prima.
Ga ik vast even kijken of we dat klaar kunnen zetten.
Ja.
Jeanette en Ignas, mooi werk allemaal trouwens.
Wat zeg je?
Mooi werk allemaal. Ik zit een beetje op de achtergrond mee te koekeloeren en te luisteren. Maar volgens mij is de interactie goed, hè?
Yeah, no. And this is let's change back to English to allow the others to join. No, but it's a joint effort, Dai. It's everyone's. It's great also from. I'm really appreciating the Australian participants for their presentations and their preparations. This is really ideal if we. Well, let's see if it's ideal in 30 minutes if we manage to bring something to Australia as well. But so far, I'm really pleased with the way that the Australians express what is going on, and also be very open about the next steps that they like to make. So yeah, I'm positive
Fantastic.
as
well. Fantastic. Well, I'll be quiet and I'll continue to listen.
Okay, that's great. Okay.
Well done. Yeah, well done.
Thanks, Dai. So we're back, I hope, at least. I suggest, Jeanette, you mentioned that the order of the Dutch presentation is slightly different than I was just saying. So let's start with Michel from VDH Water Technology. So maybe, Jeanette, you can make the screen a little bigger. Can you go to the presentation mode?
Yeah, I've got two different
systems.
Well, I started presentation mode, but you don't see it.
No, we see just, yeah, this is it. So super. Okay. Yeah,
right.
Great. Okay, Michel, can you please take the floor for the coming 8 minutes?
I will. Thank you. Thank you for attending. My name is Michel Betzold. I'm of VDH Water Technology. I'm sorry, I don't know how the slides work, so the next one is okay. All right, thank you. VDH Water Technology is founded in 1978, manufacturer of salt, well, I have to say chlorine electrolysis machines. The thing is, that's the only thing we do, but we know a lot about it. We are situated in Holland and in Canada. As you can see, the installed base at the moment is around 2,100 units worldwide, and our mother company is prominent in Germany, and that's why we have a large output worldwide, because there are about 80-85 outlets in all areas. As you can see on the picture, that's where Prominent is situated. Also in Australia, very well subsidiary. One of the guys is also present at the moment in this situation. It's Heath Selmans. And if you want to contact one of us, it's always good. Can you do the next one? Thank you. You can click one or two times again, because then we got the whole picture. I think that's easier in the short version. What we do is basically produce chlorine in the machine based on membrane technology. That's a lot of machines are supplied with the membrane technology electrolyzers. To make it simple, we want to avoid salinity in the process water, improve safety. If you look at the chemical side, reduce byproducts in the process as well. And then I'm talking mainly about chloride, let's say the Cl- and chlorate, which is especially in the food and beverage and agricultural sector an issue at the moment. Maybe not in Australia, but if you are exporting from Australia to Europe, it will become an issue as well. Chlorate is a hot topic at the moment. We can do a special chlorine product where the chlorate level is very low. So it's due to the produce and supply chain. The chlorate will not build up too much in order to have to meet the limits within the European community. Next to that, we can also make some improvements. It's a small contribution to water saving and water quality. Can you do the next one, please? Thank you. I got some examples. One is in the horticultural sector, circulating wash water. We were facing up an issue of one of our customers, spread of fusarium, and also the limited availability of fresh water. And the crops itself, in most cases, are very sensitive to changes and some other particles in the water. What we can provide in this situation is a water intake reduction of 78%, which is important because everyone is suffering from water shortage in a lot of cases. Also a strong fusarium reduction, still maintain the water quality, and the TCO increase is limited, but there's only 6 weeks a year operation, and this is quite extraordinary. All right, thank you. The dairy sector, we had a business case at Arla Foods in Holland. It's a specialty dairy company. They do a lot of changes a day in production. So they also do a lot of CIPs per day because of the specialty switches. Therefore, they use a chemical from Ecolab, which is highly costly. But that's not the most important thing. It has to be heated up. And because of the chlorine product with a very low chlorate and chloride could be used instead, they didn't have to heat up. So they could save on gas, and that's a lot of money. Therefore, the business case for Arla was very interesting. And also the fact that for each CIP, they didn't have to cool down the system. So they don't have waste of product, which was heated up. It saves a lot of time, which increases the product production capacity. And the chemical storage was less. The utilization of the product line, as I said, you can produce more a day. and the service of third parties on site, they found was important to decrease the number of parties. And we got an example of potable water. This is in the Czech Republic, where chlorate in potable water is a very important parameter. And this is why they always had to use chlorine gas as a disinfectant. But due to the safety risks and also the transportation of flasks of chlorine gas, they were trying to find another way. Because we manufacture the electrolysis machines, we can make sure that the chlorine product coming out is on spec of the customer. And this is why we are not doing rocket science. The only thing is we can adjust the machine in order to produce the chlorine product demanded or wished. The result is that they had 4 machines in this facility. It's the Baak water company. And they could have the same quality as the chlorine gas, but out of an electrolyzer only using salt, and still have a not too high operational costs a day. Can I have the next one, please? Thank you. Well, talking about effluent and paper mills, in Holland we got 3 paper mills situated and owning their own wastewater company, more or less. Well, it's a reused plant. They are the 3 shareholders, and the water coming from the paper mills is reused, and the reuse is possible because of the water treatment of the effluent. They had a chloride accumulation in the water treatment, and they want to reduce it, which was coming partially from the chlorine used, the commercial bleach, for disinfection. In this case, the disinfection of chlorine is still done only out of an electrolyzer system, and the electrolyzer system is producing, in this case, also the highly purified chlorine gas, and it is sucked in the process directly. They had some other issues. They are using a lot of caustic for the membrane bioreactor. The caustic produced out of the machine is added to the caustic they are using, so they are purchasing less caustic. And also there's a CO2 stripper on site where the anolyte of the machine, which is the waste, could be used because it's highly acidic instead of CO2. Well, not completely instead, but it's all about the resources and how to improve the footprint.
You have 1 minute
economically and
1 minute left.
Yeah, that's okay. I'm almost ready. And well, that's it. We got a lot of examples I can tell you about, but if you got some particularly situation regarding disinfection, we can help you with that. Thank you for listening.
Thanks, Michel. And I saw already that Stuart responded to your remarks about the rate issue, so you can get back to him. And possibly for Gippsland Water, in their wish to go to this Class A water, I can imagine that disinfection plays a role there. And also you have this case on this paper mill. So a lot of hooks, I would say, to continue discussion. Okay, let's go to Willem Baak. Willem Baak, you are working for Water Future, and please inspire us.
Okay, thanks for this invitation and all the nice talks from Australia side. Please, next slide. The tech talk about water reuse. I'd like to guide you a bit about the sustainable food production with minimal water. So looking to the greenhouses in the Netherlands. I'm owner and CEO of Water Future. We started in 2017 to add value to the greenhouses and to solve problems over there. And this I'd like to share with you. Next slide, please. First, Water Future, short intro. We are a startup. In the meantime, we are now a small medium enterprise. We are funded in 2017 and we're going well. What is our specialism? It's water purification systems. And it is electrical driven. So we use electricity, no pressure, no RO or NF or whatever. So we have dense membranes, and we use membrane technology. Basically what we're doing the research, the development, we make our own materials, and we produce the total system as well. As you can see here, a small example. The system which you see here is, for example, suitable for 12 hectare greenhouse. I will show you that later on. What kind of applications do we have in several markets? It's focused on the recovery of water, the recovery of valuable nutrients, fertilizers, salts. So we are different from our own. So that part I will explain later. And we are able to create high concentrated streams for reuse. For example, if you have fertilizers, you want to have a certain concentration. Otherwise, it's very difficult to use it again. We're only looking at the sustainable innovations. That's our DNA. We're looking for reuse instead of decompose and produce. And also we are aware that it is cost effective. It should make sense. The next slide, please. What is our specialism? I would say electrostatic desalination or electrodialysis. That's more or less the same thing. It's a kind of battery. We have no chemical side reactions. It's more sustainable, more safe, and more cost effective. And that's also, it's suitable for smaller application. We can also do bigger application, by the way. But for example, here you see a system which is able to operate a greenhouse of 5 hectares. So it's a small system, but it do the job. The second innovation is ion selective desalination. So we like to separate monovalent ions from multivalent ions, for example, and to get rid of the sodium. That's the main focus, get rid of the sodium and sometimes a bit of chlorine and keep all the fertilizers inside. We have dense membranes, important to know, so no organics are passing through, also no pesticides or whatever. So you get, and we have a high concentrated waste or product. So next slide. Then about the greenhouse food production, the most sustainable way. I like to guide you through this. So next slide, please. If you look to the bigger picture, we have water shortage worldwide. And if you look to the water consumption of the 1% fresh water, around 70% is used in the agriculture. So if we really want to solve problems, we should take care that the agricultural part is going down. And looking to the world population, it will increase. So we have starting to act. And then next slide. And then if you look to the Dutch greenhouse, that might be an interesting concept. I summarize some facts. The Netherlands, we are a small country, but we are the second biggest food exporter. We have double crop yields than if you do it on open ground. And there's a lot of collaboration there. Universities collaborating with companies, and a lot of initiatives are there. But the most important part is that you have a 90% reduction of your water usage. And that's really the game changer. And partly it's a bit amazing because, we are densely populated, and the number one is USA. But there's and if you look to the service areas, 270 times bigger. So let's look to the greenhouse in the Netherlands. Next slide, please. This is a nice picture of the Netherlands. You see some cities, and you see a lot of white roofs. So even the seaside, and all these white roofs, these are greenhouses. So it's really urban farming, I would say. It's really urban farming, and then you can imagine, and that goes quite well. We produce well, but there are definitely some environmental problems. And what's happening? The water is continuously reused, so they are not. They have a substrate, and they are continuously recirculating. They use the fertilizers, reuse it continuously. They use pesticides. That goes all well, but at a certain moment, sodium is increasing because sodium is not taken up by the crops. And then they have to discard, and then the problems are getting in. Pesticides are released, it has to be first degraded, so that part is now by legislation cancelled. But we still have some environmental issues. We have the problem with the nitrogen emission and the water shortage. And on long term, the government said in 2027 we should be able to produce crops without zero emission of nitrogen and water. And that's quite ambitious, isn't it? So what are the issues there? The first problems is the nitrogen, the emission to the surface water. You get some blue-green algae, which is not likely. And also our biodiversity is affected. And if you look to the Netherlands, we have around 9,000 hectare greenhouse, and we emit this to the surface water. So that's not good. So the second problem, the next slide, please, is maybe you say, well, if it goes to the sewer, then it's fine. But that's also not the case, because you have biological treatment. Nitrate is converted to nitrogen. And in this process, 3% is converted to nitrous oxide. And that's a 300 times stronger greenhouse gas. So that affects the global warming. And also it's a bit strange to have decomposition, nitrate decomposition. It's a linear economy. You start to produce and you're decomposing. And that's not what you like. You should to recover it. And to have, and also it's known that nitrate production is very energy intensive. So a circular solution is needed here. So and then the last problem is the water availability for greenhouse. It sounds silly, but even in the Netherlands we are getting droughts. We have less rainwater. They can collect less rainwater, and sometimes they have shortage. They start to use reverse osmosis, but then they have brine issues. So now really there's a search for alternative water sources. It can be tap water, well water, but even effluent water is tested. I saw one in the presentations. We did an experiment in Belgium with effluent water to grow cucumber, and that went very well. We could not see any difference. So we pre-treated the water with the system, and then everything went well. Quite often these water sources are not, you cannot use it because sodium content is too high. So you cannot recirculate. It starts to build up too rapidly and you have to discard too fast. So what is our solution? This is the current systems. They have drain water and a recirculation tank. And if sodium is too high, they start to discharge. And you see all the you want to get rid of sodium and chlorine. But there's potassium inside, nitrate, sulfate, phosphate, calcium, pesticides. This is common technology, and then the next part is our solution. What are we doing? We're treating on the recirculation tank. We can continuously removing the sodium, so we get it out. Unfortunately, also potassium nitrate is separated. But we have a nitrate recovery system with an ion exchange resins. And then we regenerate with potassium hydroxide to get it back to the greenhouse again. And then at the end, we have only 5% water loss. So we are nearby zero emission of water and nutrients. It looks maybe expensive. Maybe back to the last slide of the first slide, please. Yeah. It's very profitable for the growers. So they have control over the total process. The sodium numbers are not raising. They do not have to discard. They have better growing conditions, better feed conditions. They have control of everything. So we hope that the first are running in the greenhouse on 12 hectares. It shows that it's working. Still some work to be done. And then ends up to my final sheet. Next, please. I think in the Netherlands the needs are high, but maybe in Australia there might be, and looking to the presentation, I see several opportunities. Research partners to adapt this technology in Australia, and we are open for all collaboration styles. And yeah, everyone is welcome, I would say, and who have recovery issues of salts, minerals, even volatile fatty acids or water. That's it.
Super, Willem. Thank you very much. And a great invitation. So in fact, you have a solution on the one end. On the other end, you have an invitation for tech companies to help you out there in delivering the technology in Australia. So this may be an unexpected, let's say, invitation for anyone in this call or who may know tech providers who like to sort of take your technology from the Netherlands and start delivering it in Australia. Please have a look at the chat. Stuart is asking what you are doing with the sodium after the removal. So where does it stay? I assume in the 5% water that you discharge, but please give some answers to Stuart on how you see your vision, because you are, of course, then creating a brine. And so what is your vision there on what should we do with the brine then? Thanks, Willem, for your presentation. And let's go to the last presentation of today, Thijs from Nijhuis Saur Industries. The floor is yours.
Thank you. My screen is shared?
Yep.
Okay, good. So working with Nijhuis already for 8 years, proud to be here in the part of the team. We are currently part of the Saur group, and we have we're working on the mission water. And I think this topic of today is also highlighting the challenges, but this is also our mission with the company to make sure that everyone also sees the value of water, and not it's just a resource that it is something we have and we can use, but also it has a value, and only if people see it's the value, we can work together cross industries and cross countries to develop sustainable infrastructure. So today I've got a few two examples to highlight what we are doing in that. But as said, Nijhuis is part of the Saur group. We in the industrial water division, but beyond that we also have the water services and the water engineering, serving both municipal and industrial clients. So that's also why we try to bridge also the gap between these kind of topics. And it's good to see today also there are the municipal domestic part is in this call also, and also the industries, because there is something to bridge. In this first reference is a project in Poland, a large slaughterhouse capacity, one of the biggest chicken processing in Europe. For the context, we have to process a chicken into meat. You require roughly 10 liters of water for every kilogram of meat, which requires then on an industrial scale where you have 15,000 birds on the production line. During the day, you require more than 3,000 cubic meters per day to produce all your fresh meat. But on the other hand side, you're also creating 3,000 cubic meters of wastewater. So with this client in Poland, we have been working already for 10 years, and they've been developing different processing sites of slaughter lines on this site, and they have currently already 3 slaughter lines in production and rendering facility with reuse. So how the site developed, they have their own boreholes to get the water, fresh water for the production line. We realized for them the primary treatment and biological treatment to have safe disposal to the river in 2013 on the first line. It's just relatively straightforward technologies that we produce in-house and deliver. So screening for large particles, feathers, bones, flotation units for fats, oil and grease, aeration ponds for biological stabilization, and clarifying technologies based on, in this case, sludge clarification, with flotation units to get finally safe disposal to the river. And I thought it was interesting for you guys in Australia. We still suffer winter here. Last week we had a lot of snow in several countries here. We hope the spring is coming soon. But safe disposal to river, also that's here a topic in Europe. So with expansion, second expansion 2016, more well water, more expansion of the wastewater treatment plant. In addition, biogas utilization, biogas production from the waste streams. And in 2018, the third slaughter line with additional packages. So all in all, just make 3 times all the infrastructure. That was the strategy those days. And a glance of the biogas production by sludge digestion, and also the waste streams from the primary treatment, fats, oil and grease, to make biogas for the internal heat and energy production. As you see here on the site development on the north, it was started with an open field. Slaughter lines developed on the north side. You see first line, second line, third line on the north side, and at the bottom side you see the wastewater treatment plant developing from a few single tanks to a lot of tanks. But also what you can see from this bird eye view is that also the soil conditions already, just by simple bird eye view pictures, you see that it's more sandy. The climate has an impact here on this side of Europe as well. This is Central Europe, Poland, Western Germany, of Eastern Germany, Romania. In this case, we really have a lack of is unbalanced rainfall versus the evaporation. So also this client was suffering problems with the wells. So even though they had the wells were not producing sufficient amount of water. And on the back end side, because of the climate change and the drought, the impact of the slaughterhouse on the river was so big that even the local authorities were giving a limit on the amount of water that could be exposed back to the river, even it was a good quality. So limitations were given. So all in all, the installed slaughterhouse capacity was not capable of running because just there was no water. So water was the limiting factor. We developed with them together a master plan. So beyond wastewater treatment, also recycle water from disposing to the river back into the front end treatment, but with the main purpose, it should be drinking water quality. They didn't want to have a differentiation between boreholes or reused water for different classes. No, drinking water quality. So to go into that direction, we had an extensive pilot trial period to prove to the local authorities, local drinking water authorities, that we can produce drinking water standards, and also with all the certification, all the performances. And on the other hand side, for the processing side, for the meat processing, that it's a stable performance because it's a critical source. After the pilot, the system is designed for a total 8,000 cubic meter per day of water reuse to substitute the boreholes. 4,000 cubic meters, so 50% of it is installed now, supporting the existing plant, and the client is considering further growth of additional slaughter lines, and then they can utilize the total building. It's a build-up of relatively traditional sand filter, ultrafiltration, reverse osmosis, but the challenge is here, of course, the interaction between an industrial wastewater treatment plant on the one hand side, so all the different variations in waste you can expect. Also rendering is connected to the wastewater treatment plant, and on the other hand side you produce drinking water, real drinking water, which is certified. So all these belts and braces had to be implied. You see a few pictures, sand filters to have extra belts and braces prior to ultrafiltration for bacteria and virus removal, and 4 banks of reverse osmosis to remove all the dissolved matter up and beyond the drinking water quality. And after this, the water is blended with it's disinfected and then blended with the borehole water. And as a mix, it is going into the facility. So nowadays, on average, more than 3,000 cubic meter a day recycled, good balance, and the client is capable by this to think about future expansion, even though without further impact to the nature. Other topic I'd like to highlight is the urban farming. So urban farming is something which is developing and is rapidly developing. And we have to do, because you see on the world population, if you purely look to the 2050 outlook, we are with 10 billion people. And from this 10 billion people, 70% is living in cities, large cities. So everyone on this world now will live in only 30 years time, within 30 years time, in big cities. If you imagine that, in combination with the climate risk, drought, flood, and result of food scarcity, how do we survive? So we know that this is coming. How do we survive? So can we learn and adapt from other areas? And here I'm starting to go into the agro industry that we do already today. So we see that the universities, and also in the Wageningen University, but probably also in Australia and different countries, you see that the technologies are developed with satellites, with smart sensoring, that you already get a good understanding of your fields and how your crop behaves, and which part of your field requires specific fertilization, so precision fertilization, and also a specific irrigation. So this is already what is developed from the one hand side on the agro industry. And on the other hand side, as a reference, we also from a technology side develop technologies where we can recover the nutrients from of the waste streams from manure digestions, co-digestions. So rather than just have a blend of digestate, which is a blend of water, nutrients, organics, and you can use for irrigation and fertilization, we already have developed now technologies and references where you separate all these valuable stuff in individual streams, phosphate streams, nitrogen streams, potassium streams, and water, which you can really use for precision fertilization and precision irrigation. An example, technology, ammonia recovery. So by stripping technologies, you really recover the ammonia from of the digestate into a ammonium sulfate or ammonium nitrate fertilizer, a liquid fertilizer. Another technology that can be applied is membrane technology. So with a series of membranes, you can concentrate all the nutrients into the brine liquor you see here at the back end. It is RO brine, but it's full and rich of your nitrogen, potassium, and any residual phosphorus. So with these technologies, you produce the fertilizers, the liquid fertilizers, that can be applied with also the development on this precision fertilization. Also what is happening is the city farming. And guess what? In the city farming on glass towers, and they don't need digestate, they don't need manure, they need the concentrated nutrients as this product. So this is happening today already in many big cities where the food is produced inside the cities. So can we also recover ammonia from cities? This is the skyline of New York, Manhattan. Guess what? This is the sewage treatment works of New York. So it's really close. So we already concentrate all the wastewater with the nutrients from the municipal people, from ourselves, in a centralized treatment works. But what we do currently today, large aeration ponds, and what do? We blow all these valuable products away. So all the nutrients, of course, we convert as sustainable as possible, but still we risk a lot of emissions of nitrogen, laughing gas, NOx, currently with this treatment works, and we just blow it away. We bring it back into the air. So can't we apply these technologies that are already developed for the agro industry? Can't we apply this already in the cities? Just an example, yes, we have the first reference already in Europe. This is a site in Germany where our sister company in the group, in the Saur group, Biosys, already developed the ammonia recovery in sewage treatment works, where the domestic sewage treatment works is invested in ammonia recovery on the liquor stream, and the local farmers are taking the ammonium sulfate and bring it for the field irrigation in the spring. So already here is an example where you bridge between domestic wastewater treatment plant and agro industry to reuse your field. And this maybe also is to tie in on the, I think it was Simon, which was highlighting, for example, where the effluent from the sewage treatment works is salt. And part of the salt is probably also the nitrogen. So if we remove the nitrogen on the sewage treatment works on the one hand side, we can reduce, for example, the salt content in your main aquifers, have a fertilizer on the one hand side already, and have more the water on spec, which you can use for irrigation purposes. So that's one of the things I'd like to tie in later on that topic. So we can create a resilient urban living. We are working on this. We are part of this development. So yeah, I'd like to team up with opportunities in the UK, or in Australia.
Thanks, Thijs. Thank you very much. I've seen this presentation for the second time now, and this time it really landed because there's so much information in your slides. But at the same time, the first time I was already aware that it is so complete and so forward-thinking. So I invite everyone. This session is being recorded, and we will publish it online on the YouTube channel of ENVAQUA. We will send some notes or an email or anything around in the coming days with the link of this session, and there you can also watch back to this and see all the details. There are so much details in the slides of Thijs as well, and process them. So thanks, Thijs, for your presentation. Let's We have a few minutes left, 2 minutes left, which is slightly too short to have a proper discussion. And for that, we thought about this already. We invite all of you to get back in a call the 12th of May to see where we are. In the coming days, I will make sure with Jeanette that we will send an email. I'm thinking, Jeanette, that we send an email to all participants that enables them to contact each other. If you don't want this, if you don't want your email in this wrap-up email, then send us in the chat that you don't want to be involved. Otherwise, we will share the emails amongst all of you that allow you to connect directly with people that you like to be in touch with. And we will share the link to the YouTube recording. And also, then this is the announcement, 12th of May, same time as this call. When I did my preparation correctly, it was 4:30 Australian time when we started. Same time, we will get back to each other and see what kind of connections have been made and what kind of new questions, or maybe you have questions that you still want to address, then please bring them to us 12th of May. Unless anyone has anything urgent, which I don't see in the chat, so I'm confident that it's all have been clear. I want to thank you very much for being here, for being open, for being inspiring, for reaching out to the other side of the world. I saw a lot of things going on the chat already, so let's take this further, and I'm looking forward to see you back 12th of May. Thanks very much. Have a great evening. Have a great day. Ciao.
Thank you.
Ignas?
Ja.
Nog even... Ja, met de Nederlandse bedrijven blijven nog even na. Dat is
goed. Zullen we eerst even de opname stoppen, Jeanette?
Oh, dat is waar ook. Opname stoppen. Goeie.